This is lesson 10.6 on geometric series. A geometric series is a series that results from adding the terms of geometric sequence. We do have a formula for this, so let's look at it and identify the parts. So a sub 1 is your first term. N is going to represent your number of terms. And R is your common ratio for the geometric sequence. All right. So let's use this formula to find the sums. Let's look at example 1. And we want to find the sum of S sub 6. So we have to identify N. N is going to be 6, that's the number of terms. A sub 1 is your first term, which is -4. And the common ratio is going to be -3. And the way we did that was, again, remember, to find the common ratio, you take a term and divide it by its previous term. So that will be -3. And then we've substituted into the formula S sub 6, because we're looking for the sum of 6 terms, equals -4, your A sub 1, parentheses, 1 minus your common ratio, -3, to the n power, which is 6, divided by 1 minus your common ratio, which will end up being 1 minus -3. When you calculate that, you should get S sub 6 equals 728, and that is the sum of that series. Okay, let's look at example 2. Again, we want to identify our information, so N is 8, your upper limit. A sub 1, we have to substitute in 1 here, so 1 minus 1 is 0. 3 to the 0 power is going to be 1. And R is going to be 3, right? We know that this is going to be our common ratio. And you could substitute in 2 if you're not sure to figure that out. Okay, so S sub 8, right? We're looking for the sum of 8 terms, equals 1, parentheses, 1 minus our common ratio of 3 to the 8th power, our number of terms, divided by 1 minus our common ratio. And that will calculate to 3,280. All right, moving along to example 3. N is going to be 7, and A sub 1, we don't know, so it's 3 times 6, 1 minus 1 is 0, so we know that's going to be 1, so it ends up being A sub 1 is 3. And my common ratio is going to be 6. Okay, and again, if you're not sure how to identify that, you can substitute in 2, right? 2 minus 1 will give you 1, so 6 to the 1 power 6 times 3 is 18. 18 divided by 3 is 6, right? So you'd have 318, and you would just do that division to get your common ratio. So S sub 7, substitute everything in, divided by, and we calculate, and this is a large number this time, in a decimal, we have 167,961.6 as our sum. All right, one more example. So we have S sub 9, so we know that's what we're looking for. We have our first term, we have our common ratio, and we have our number of terms divided by our common ratio, 1 minus our common ratio, and you calculate it to get 2,044. So sometimes when they give you this information, you're just substituting it into the formula and there's no added information you need to find. All right, those are series that actually, you have S sub 9, F sub 7, you're looking for a certain number of terms, the sums of a certain number of terms. What we're going to look now at is infinite geometric series. And we're going to recognize that there's 2 types, convergent and divergent. So let's look at convergent. We have 4 plus 2 plus 1 plus 1/2 plus 1/4. Okay, and to find the sum of 1, we just know that that's 4. It's just the first term right here. S sub 2, you add the first two terms, which would give us 6. S sub 3, you add the first three terms, okay, which would give us 7. S sub 4, you're adding the first four terms, which gives us 7.5. S sub 5, the first 5 terms, 7.75. Okay, and some of these I have to now start finding its 1/8. So 7.75 plus 1/8 would be S sub 6. And we keep going and keep going. And what we're going to realize is we're going to get to some number, okay? And so convergent series, okay, of infinite geometric series will eventually, if you keep going, adding the terms to infinity, it's going to come to some number. All right, and we can see that that number is going to be 8 in this case. All right, so let's look at that. We can see that our ratio was 1/2, and when our ratio, the absolute value of it, is less than 1, we're going to call it a convergent series. Okay, so maybe you even want to write that up here. When the absolute value of r, your common ratio, is less than 1, it's convergent, and it should go, okay, it should go to some number. All right, the series should be, the sum should be some number. All right, let's look at divergent. All right, S sub 1 is 1/4. S sub 2 is 1/4 plus 1, which is 1.25. Okay, we're going to keep adding the 4 terms, adding 5 terms, adding 6 terms, 7 terms, and we keep going. And we can see that our numbers are just going increasing, increasing, increasing. So we can see that it's going to infinity. So convergent, okay, is when that ratio is less than 1 and it goes to some number. And divergent is when the ratio is, let's look at it. Okay, the ratio was 4, and you can see that here. 1 divided 1/4 is 4. So it is greater than 1, and our S sub n is going to be infinity. Okay, so when we have geometric series that are infinite, we know that it's either going to be the sum of a number or infinity. Okay, so when it's convergent, we want to know what that number is. All right, and we have a formula for that. So it says determine if the series is convergent or divergent and identify the common ratio, the absolute value of the common ratio. Find the sum if it is convergent. So I'm going to look at this and think my ratio, 8 divided by 4, is 2, so it's greater than 1, my absolute value, so I know that it's going to be divergent. Okay. In this example, I can see that my common ratio is 1/3, so it's less than 1, and therefore it's going to be convergent. And I'm going to use the formula to find out what number is going to be for the sum. And I substituted in 1 times parentheses 1 minus, or divided by 1 minus 1/3 to give me 3/2 or 1.5. So that would be the sum of that series. Okay? Again, this is lesson 10.6 for geometric series.